Okay, so here we're using the Pythagorean theorem repeatedly so that we can find the line segment CD, which is in this picture. So if you're looking at this picture right here of this triangle, we can see, I'm moving stuff around. I'm just getting used to this. Okay, so now I found the two I'm looking for. So there's three right triangles in this figure. If you can follow me, I'm going to try to outline them in different colors. So we'll start off with white. Right here, starting with C, we have a right triangle that goes down to D, cuts down right here from D to B, and back up to C. Second right triangle starts with D right here, goes to A, goes to B, and back up to D. And our third right triangle starts at C, goes to A, right here, C to A, from A to D, and from D back up to C, right there. So there's three right triangles in this figure. So since we're using a right triangle, or since these are right triangles, we're going to be using the Pythagorean theorem, which is a squared plus. Okay, like I was saying, we're going to use the Pythagorean theorem, which is right over here. That's a squared plus b squared equals c squared. And we use this Pythagorean theorem with right triangles. And with a right triangle, there's always the sides. You have to identify the sides. For example, the ones that create the right angle, you see where this square is right here, are always going to be A and B, always. And the side that's opposite of the right angle will be the C, and that's called the hypotenuse. And it's always going to be the longest value or the biggest value in the right triangle. So once you identify your right triangle and the sides, then sorry for that bell. We're at school, but then we gotta go ahead and take a look at our triangle. Which triangle are we going to use? Which triangle has two values? Is it our white triangle right here? This white triangle right here, we have no value for that side. We have 55 here and nothing there. Is it our this one over here, pale yellow, I guess? We have 52 for here, nothing for that side, and nothing for that side. Or is it this orange one down here? We have nothing here, we have 73 here, and we have 55 here. So this is the triangle that we're going to use our Pythagorean theorem for. Okay, so where is it? There we go. Bring it back over here. So let's go ahead and label our A, B, and C. So our A, if we're looking at our triangle, is X. We don't know what that is. Oops, not square, but X. Our B is equal to 55 because it's one of the legs that makes the right triangle. And our C is 73 because that's the one opposite of the right angle. If you don't know, let's look at it closely right here. See, we have this side right here is my A and my B because these make the right triangle if you look at that little symbol. And this is across from the right angle. So that's why this is my C. Okay. So back to our problem. So once I have identified my A, B, and C, we can go ahead and plug that into our Pythagorean theorem. So we will get x squared plus 55 squared equals 73 squared. And with these kind of numbers, we'll be using a calculator. So hopefully you have one available for you. So here we go, x squared plus 55 squared equals 73 squared. So we'll go ahead and square those numbers out. So 55 squared is 3,025. 73 squared is 5,000 329. And we're solving for x, so that means I'm going to go ahead and subtract 3025 from both sides. Right there. And get, I need more space. So when we get what? We get x squared is equal to 2,304. So at this time, I'm going to go ahead and square root because we want to know what x equals, not x squared. So x will equal 48. So where does that 48 go in our problem? Right here, our problem, or on our figure, the 48, since we were using this triangle right here, the 48 is AD. We would have found AD. So now this right here is 48. So now that means I have two sides of this pale yellow triangle right here. This pale yellow triangle has a 52 here, a 48 here, and this is what we're trying to find. Remember, we're trying to find CD, so we're trying to find CD. So that means let's go ahead and set this one up to solve. So let's move that over here, and we have our A. Our A can be 48. Our B is the CD line right there, which is we don't know, so we'll call that X. And our C is 52 because that's our hypotenuse. So we go ahead and put that over here and put it into the Pythagorean theorem. So if we put in the Pythagorean theorem, not A, we're going to go 48 squared plus x squared equals 52 squared. All right, so don't mind the clapping in the background. That's my neighbor. Here we got, so now that I squared both numbers, I'm going to go ahead and subtract 2,304 from both sides so that we can get our x by itself. So this leaves us with x squared equals 400. And again, we take the square root. And so x equals 20. And that is our final answer because, once again, remember we were looking for the CD right here. CD, and we use 48, 52 in our Pythagorean theorem to find that. So that's our final answer too.